Hello everyone, welcome to our Material and Processing Science presentation. In this presentation, we are going to cover 4 topics. The first topic is what are the effects of alkalinity and acidity in drinking water, discuss the process of groundwater contamination that occurs, and how does filtration membranes in water purification works, and also describe the source of stormwater. The first topic we are going to discuss are the effect of alkalinity and acidity in drinking water. What is a pH? pH is a measurement of electrically charged particles in a substance. It indicates how acidic or alkaline that substance is. The pH level ranges from 0 to 14. Acidic water has a pH lower than 7. Strongly acidic substance can have a pH of 0. Alkaline water has a pH of 8 or above. Pure water has a pH of 7 and it is considered neutral because it is neither acidic or basic. World Health Organization recommends that municipal drinking water supplies keep their pH between 6.5 to 8.5. Effects of acidic drinking water on humans. Due to potential heavy metals contamination, it is not recommended to drink acidic water, as it can lead to heavy metal poisoning or toxicity. Additionally, the acidity of the water can erode toothed animals. Plants. Acid rain leaches aluminium from the soil. That aluminium may be harmful to plants as well as animals. Acid rain removes minerals from the soil that trees need to grow. On animals, at a lower pH level, some adult fish die, some acid lakes have no fish. Even if a species of fish or animal can tolerate moderately acidic water, the animals or plants it eats may not. For example, frogs have a critical pH around 4, but the mayflies that they eat are more sensitive and may not survive at a pH below 5.5. Effects of alkaline drinking water on humans. Your alkaline drinking water lowers the natural stomach acidity, which helps kill bacteria and expel other undesirable pathogens from entering your bloodstreams. Additionally, an overall excess of alkalinity in the body may cause gastrointestinal issues and skin irritations. Too much alkalinity may also agitate the body's normal pH, leading to metabolic alkalosis. In plants, if water is too alkaline, calcium builds up, effectively cutting off the flow of nutrients from the plant's roots. In animals, when the pH of a fresh water becomes highly alkaline around a pH of 9.6, the effect on fish may include death, damage to the outer surface like gills, eyes, and skin, and inability to dispose of metabolic waste. High pH may also increase the toxicity of other substances. The second topic to be discussed in details is the process of groundwater contamination that occurs. Process of groundwater contamination. What is groundwater? Groundwater is the water that exists in saturated zones beneath the land surface. Although groundwater is located underground, it can be contaminated through the following sources. The first source is chemicals. Chemicals used on lawns and farm fields to kill weeds and insects and to fertilize plants, and other products used in homes and businesses. When it rains, this chemical can seep into the ground and eventually into the groundwater. The second one is road salt. Road salts are used in the winter time to put melt ice on roads to keep cars from sliding around. When the ice melts, the salt gets washed off the roads and eventually ends up in the water. The landfills. Landfills are places that our garbage is taken to be buried. Landfills can have a protective layer to prevent contaminants from getting into the water. If there's no layer or it has cracked, contaminants from the landfill, such as your car battery acid, your paint, your household cleaners, etc., can make their way down into the groundwater. The third topic to be discussed in details is how the purification membrane works in water purification. Filtration membrane is defined as an essential microporous barriers of polymetric, ceramic, or metallic which are used to separate dissolved materials, colloids, and fine particulate from solutions. There are 4 basic pressure-driven membrane filtration processes separation, namely your microfiltration, ultrafiltration, nanofiltration, and also your reverse osmosis. These processes differ based on the size of particles that can be separated and the type of substances that can be passed through the membrane. The first filtration membrane is microfiltration. Microfiltration is the direct removal of suspended particles using a membrane which separate according to particle size. It rejects only suspended solid, while allowing even proteins to pass through the membrane freely. The membrane can be symmetrical and asymmetrical and has a thin film of 10 to 150 micrometer. The size of the surface pores of the membrane is between 4 to 0.02 micrometer. Microfiltration process. Microfiltration is achieved by using cross-flow isolation, which include introducing the feed stream under pressure into the membrane and passing it through a membrane surface in a regulated flow path. The small part of the feed stream that goes through the membrane is called your payment. The soluble particles that were rejected by the membrane are washed away and are called concentrate of feed. The cross-flow membrane filtration makes use of high cross-flow rate to promote passage and reduce blockage. The second membrane filtration is ultrafiltration. Ultrafiltration is a technique that separates components in water according to molecular size. The technique forces water through a semi-permeable membrane where suspended particles or dissolved substances with high molecular weight stay behind on the retented side of the membrane. The membrane is symmetrical and has a thin film of 1 micrometer. The size of the surface pores of the membrane is between 0.2 to 0.02 micrometer. Ultrafiltration extracts many organic compounds, viruses, cells, and inorganic acids. This method generates uniform water quality regardless of the source of water being treated. It also eliminates 90 to 100% of pathogens and does not use chemicals unless membranes are being cleaned. Ultrafiltration is used mostly in water and wastewater treatment. The third membrane filtration is your nanofiltration. Nanofiltration is a method of filtration that makes wastewater to be recycled by providing a greater reflux rate while using less energy. Nanofiltration uses membrane extremely small holes down to 600 daltons. It only allows tiny and single charge ions to flow through at a high pressure like 50 bar, while bigger ions with more than one negative charge such as your sulfate or phosphate and all organic materials are rejected by the membrane. The rejection of sodium chloride in nanofiltration varies from 0 to 50% depending on the feed concentration. The membrane is symmetrical and has a thin film of 1 micrometer. The size of the surface pores of the membrane is less than 0.02 micrometer. Nanofiltration is used to concentrate and demilarize substances such as whey and ultrafiltration. The fourth membrane filtration is your reverse osmosis. Reverse osmosis is the tightest possible membrane process in separation that only allows water to pass through. Suspended and dissolved materials are not allowed to pass through. The membrane is symmetrical and has a thin film of 1 micrometer. The size of the surface pores of the membrane is less than 0.002 micrometer. Reverse osmosis process. Reverse osmosis uses pre-filters to extract residue and chlorine from the water before forcing it through a semi-permeable membrane to remove total dissolved solid. After filtration by reverse osmosis, the water is channeled through the post filters to increase the taste and the appearance of the water. Your reverse osmosis is used in desalination of drinking water and also the production of deionized water. The fourth topic to be discussed is the source of stormwater. Sources of stormwater. What is a stormwater? Stormwater is the water that arises from precipitation, which include heavy rain and melted water from heavy rain or snow. We have three sources of storm. The first one is your slot drains. They are great for outdoor areas that do not require excessive drainages. They tend to flood easily when exposed to heavy rainfalls. The second one is open storm drain. Open storm drains are drains that usually run parallel to a nearby road or parallel to the edge of a property. They feature long uncovered channels to carry free-flowing stormwater. These channels often direct water into a local sewer system where it can be treated and managed. The third one is closed storm drain. Most of the stormwater management system you see now are stormwater grates that lead to a local underground sewer system. Closed storm drain grates can be found in the lower areas of parking lots, the trenches near sidewalks, and other areas where water intentionally or unintentionally tends to collect. A special thanks to group members that contributed and made the presentation exercise. Thank you very much. This is the end of our presentation. I hope you enjoyed and learned from the presentation.